you have here in your regular syllabus also this concept already, but it will be given as a revision for also you. Yes, you are concerned. Yes, the friction already we are discussed with the components. Yes, and during the holidays also we are again go with the revision on the friction. Okay, but before going to that, we are going to discuss about the gravitation. It's a very important concept. Why? Because some parts are linked with that center of mass, gravitation. These components are again getting in a friction. The second lecture, whatever there, it will be contained somewhat angle of friction and all these things are contained based on center of mass. The last class also we are discussing center of mass based on one problem. Okay, that is why now first we are going with the physics component. Yes, and the name of the physics that is the lesson name is the gravitation. Yeah. Now, what is the gravitation? Why there is this much of interest on the gravitation? Who is the first scientifically explain about the gravitation? Before going to that, we are going to the what is the history of the gravitation lesson. It's a very important. Why? Because we are always fight in a physics, always fight with the gravitation only. Okay, the fighting things only produce so many inventions. Got it or not? Yes, we want to fly, but gravitation don't want to make it fly. Got it or not? Yes. That is why only we have to know about the gravitation. Some uses are also there because of gravitation. If a gravitation is not there, we are not walk like this. Okay, got it or not? Yeah, that is why we have to know compulsory about the gravitation. First, we have to know about the gravitation. First, we have to know the universe. Okay, universe is the infinity. You know very well. Infinity or not? Till it forms going on. Number of things are there in the universe, but everyone they are moving in their particular regions. It will be very miraculous thing or not? They're moving with the high velocities, and the stars are there. Sun is remaining planets are there. They are fixedly they contain in their positions. How it is possible? Who made it is? What the forces are going on? Why we will not fall in a sun? Yes. And as well as why the solar system contain 8 planets only? Why it is not contain more than that all the planets? Why the stars are appear in that particular form? Okay, why they not fall down? Small thing it will be like this fall down. That much of big stars are why they not fall down? These questions are may getting in a mind. Got it or not? May you not get, I thought you are not thinking about physics. Huh? Yes, when you think about these things, there is so many questions are arising in the mind of our ancient people also. Got it or not? But they given the first, there is a physics scientist, one of the scientists. Yes, Ptolemy. Okay, the name of the scientist is Ptolemy. Okay, yes, he is silent in this name. Yes, Ptolemy. Okay, the name of the scientist Ptolemy is the proposed one theory. That theory is called what? Geocentric theory. The theory name is the what? Geocentric theory. What is according to this theory? Yes, Earth is the center for the total universe. He said that the Greeks actually, the Greeks god, yes, and based on that only he proposed that Earth is the center for our total universe. According to him, Ptolemaic theory, yes, it is also called Earth-centric theory also. Yes, clear or not? Remaining all the sun, planets, remaining stars, remaining all the planets, whatever celestial bodies are there, they're revolving around the Earth only. Got it or not? Yeah, there it is about our Ptolemaic theory. Okay, clear or not? And now the next one is what the name of the scientist is may come. Okay, now he's a Poland monk. Actually, he's not a scientist, a Poland monk. He says that Copernicus. The name is what? Copernicus. He is given heliocentric theory. Okay, clear or not? According to him, The sun is the center for the total universe. Remaining all the planets and all the stars and remaining, okay, are revolving around the sun. He said, okay, now it is a second century. It is the 14th century. Meanwhile, there is a second to the 14th century. All the scientists and all the persons are there feeling that Earth is a fixed, remaining are revolving. Okay, but he not said like that. Earth is not a center for the universe. Sun is a center for the universe. That theory is called what? Heliocentric theory. Helio means sun. Okay. Yes, helio. Okay, means what? Sun. Heliocentric theory. Okay, but afterwards also so many scientists came. Okay, now but actually this whatever the heliocentric theory is there, it is not supported by the any country. Yes, the whatever the Copernicus is there is murdered by the people because of this theory. Yes, why you said Earth is not center? Why you said Sun is the center? Why? Because he not given any physical proof. Okay, he not given any physical theory for it. He said he said correct only, but he not theory. And based on that, whatever Copernicus students are there, okay, na Tycho Brahe is given one more theory on this particular solar system, our total universe system. Okay, Tycho Brahe, name of the scientist is what? Tycho Brahe. And after the Tycho Brahe, Kepler came. Kepler is a very important scientist in our mechanics and gravitation lesson. He is given 3 laws for a planetary motion. Kepler planetary motion laws. In a higher section you have here. Yes, this about these things. He said 3 laws. It is supported heliocentric theory only. Okay, now he said that yes, sun is the center for the solar system, not for total universe. Around the sun, there is all the planets are revolving in elliptical orbit. During the sun is our planets are revolving. Okay, during the planets are revolving around the sun, the angular momentum of the sun is remains constant. Angular momentum of the sun is remains constant. Got it or not? Yes, and as well as there is a revolutionary time is the point of the revolutionary time is they are directly proportional to cube of the semi-major axis. Sorry, E square is directly proportional to R cube. Okay, clear or not? This is the called of what? Kepler third law. Is a given the what about the this is the what revolutionary time. This is the sun. Okay, around that there is a moving in elliptical orbit. Na this distance is the called R. Okay, na? And as well as the total time taken. Suppose Earth is there 365 days. Okay, clear or not? Yes, and as well as there is a whatever the planet they consider. Okay, the planet is contain somewhat or what actually revolutionary time. Okay, clear or not? The revolutionary time is a directly proportional square of the revolutionary time directly proportional to cube of semi-major axis. This is also given by Kepler. Okay, now in this base for all these theories, Kepler theories is what you know. Yeah, our great scientist, who's that? Newton. Newton is a proposed one great theory that is only called the Newton gravitational law. Okay, now our lesson is started from not from this all. Okay, these all are we have in our textbook also. Yes, about the Newton gravitational law, which is called Newton gravitational law. Yes, Newton gravitational law. Yeah, you know very well all the students. Yes, what is the Newton gravitational law? According to the Newton gravitational law, every 2 bodies in the universe, one is attracted with the another one. One is attracted with the another one. With influence of one great force that is only called gravitational force. Okay, clear or not? That is directly proportional to the product of its masses. It is inversely proportional to the square of the distance between them. Got it or not? Once again, and repeat it. This statement is a very important for your regular syllabus and as well as the IIT purpose. Not only that inverse square law is used for the gravitation purpose. The same law it is available in a Yes, what it is? Electrostatic forces purpose, magnetic forces purpose also. Okay, clear or what? Whatever non-contact forces are there, for all the non-contact forces purpose, may it is applicable. Okay, clear or not? Between the two charges, between the two magnetic poles also, may formula is the same. Okay, clear or not? For a gravitational law, as how it will be contained as a inverse square law, the same law it is applicable for the what? For the electrostatic charges between the two charges, between the two magnetic poles also it is applicable. Just there is the terms are only changes. Okay, now that is why this law is a very important. What he said, any two bodies in the universe, not only the U and V, not only the mass and Earth and Sun, not only the Earth and Moon, every two bodies. This chalk piece and this mobile phone, this chalk piece and you, everything is the one is attracted with another one. Sir, how sir? You are there and you are here. Yeah, attraction is there. The attraction is nothing but not attaching. Okay, na? From the, you know very well about the two types of forces are there. One is the contact forces, another one is the non-contact forces. Okay, na? Without a contact only, one body is the influenced another body, either in state or in a shape or in a direction. Okay, clear or not? Yes, and that is called what? Non-contact force. That is our gravitational force is a what? Non-contact force only. It is a called field force also. It is a giving its effect from some particular distance only on the body. Got it or not? That is why the gravitational force is the working between the two bodies. It is a taken somewhat a capital M, somewhat it is a small m. The distance between the two bodies are taken as the r. Okay, now? Yes, it is attraction force only. It is not a contain repelling nature. Gravitational force is the attraction force only. Yes, every two bodies in the universe, one is attracted with another one. One is attracted with another one. Understood or not? Now, there is a what is acting? The force is acting. F is directly proportional to product of its masses. F is directly proportional to product of its masses. F is inversely proportional to square of the distance between them. Okay, means what here? Where we are taken a big masses, more force may available. There is a very small forces masses where we consider the product is also become small. That's why the gravitational force also become small only. Got it or not? When there is a distance between the one body to the another body increases, okay, now there is a gravitational force become decreases. The gravitational forces become decreases. Got it or not? I hope you got it here. F is inversely proportional to the square of the distance between them. Means what? Suppose Pluto. Why the Pluto is already it is the one of the planet only in our solar system. Our family planet only, but it is not considered as a planet now present. Yes, in your childhood, may you don't know you are taken 8 is only planet, but in my childhood I am read it is as a 9th planet. Now it is not considered as a planet. Yes, it gets somewhat asteroid nature. Okay, now and it is now there is a actually it is in a solar system only, but it is not look like a planet property. Okay, now why? Because it is far away from the sun. Okay, now yes, and after the scientist, it will be removed from our planet family. It's not a planet; it is one of the asteroid only. Okay, clear or not? Why? Because that much of gravitational force effects are not given. Planet is a contain one such type of gravitational forces. Pluto is not provide that much of things. Okay, clear or not? Yes, that is the one reason. There is a which one is the contain more gravitational force of sun in our solar system? Mercury. Why? Because it is very nearer to the sun. Okay, clear or not? Yes. Now, which one is the container as the least gravitational forces on? Yes, Neptune. Okay, now yes, clear or not? Last planet. Like that, there is a when it is go away from it, automatically gravitational forces decreases. When the two bodies are separated with max distance, more distance, the gravitational forces decreases. Got it or not? It is inversely proportional to one another. This is equation number 1 you have to take here. This is equation number 2 you have to take here. Now, yes, combine equation 1 and 2. Combine equation 1 and 2. What is it now? it will be taken as F is directly proportional to m into m by r square. F is equal to taken as g into mm by r square. This is only called what? Newton gravitational law. Here g is the called gravitational constant. It is a called what, Nana? It is a called as gravitational constant. I hope you understood it is. Yes, the g is the contained value, that is a 6.6 into 10 to the power of minus 11. Okay, clear or not? 6.67 into 10 to the power of minus 11 Newton meter square by kg square. Okay, clear or not? This is called Newton gravitational law. G is a what here? Gravitational constant. It is a what it is? Gravitational constant. Gravitational constant. G value is 6.67 into 10 to the power of minus 11 Newton meter, yes, by kg to the power of 2. Understood all of you? Newton meter square by kg to the power of 2. Okay, this is only the units of Newton gravitational constant. Okay, yes. And here next we are going to what is the G value and what is the definition of G also. Once please note down up to here. Newton gravitational law. You know very well what is the law. Yeah, next concept here. Yeah, they given what about the G? Significance of the G. What is the significance of the G? And why we are required it is, yeah, the G value is a very important. How can you get? You substitute the any masses. Here M is the small, what a big mass, small mass, whatever you taken. Yes, and as well as we know the gravitational force between the any two bodies. Okay, now you will get it is. Yeah, once check it here. Suppose I am m is equal to 1, I am taken. Small m is equal to also I am taken a 1 kg, and both are taken a 1 kg, and the distance between these two bodies are taken as, okay, 1 meter distance. What happened? Yes, now from this equation 1, capital 1. Yes, above values substitute in equation 1. Above values substitute in equation 1. What we get? We get now, what we get it is now f is equal to taken as g. Why? Because 1 into 1 by 1 square. It is equal to what? F is equal to g. Yes. Then how we define the g by g here? How we define the g here? Yes, there is a 1 gram or 1 kg body is attracted with another 1 kg body with a distance of 1 meter distance. Okay, now that force, the gravitational force is acting on the bodies are equal to, yes, the gravitational constant. When the two bodies are contained 1 kg distance, 1 kg masses, and separated with the 1 meter square distance, that is called what? Gravitational force. That is called what? That gravitational force is only called what? Gravitational constant. That is only called what? Gravitational constant. I hope you understood. Once again, I am repeating. There is any two bodies are contained 1 kg mass and they separated by the 1 kg distance. They separated by the 1 kg distance. The gravitational force acting between the two bodies is called, yes, gravitational constant. Okay, clear or not? The gravitational constant value already we have discussed. That is only 6.67 into 10 to the power of -11 Newton meter square by kg square. How is the value is get very well? Yes, how the units are get very well. How? There it is a meter. F is equal to what we have taken? Meter into meter. Yes, clear or not? Meter into meter. That is taken as G is equal to what will be get? G is equal to taken as F into R square by M into M. It is or not it is? Now there is a units are become Newton, meter square, kg square. Clear or not? How will we get the units here? Newton as R is the what? Distance square, meter square by kg into kg. It will become what? Newton meter square by kg square. These are the units findings for the G. Got it or not? Yes. And this is give the definition. What is the definition for the gravitational constant? When we applied a 1 Newton force is between a 1 kg masses or otherwise any two masses are separated by the 1 meter distance. Okay, now which are contain 1 kg mass each. The whatever gravitational force is between them is equal to, yes, gravitational constant. Okay, clear or not? That is only the thing. And the units are important. How to write units? You'll get it is now. There is a G is equal to formula is the what? G is equal to formula. You'll get S units of G. Units of G. Okay, I will be get. And here F is equal to what? F is equal to G into mm by R square. Then G is equal to what? F into R square by m into m. Here, what is the units of force? That is become Newton into what is this is distance. That is a meter square by kg into what? Kg. Now the units of G is equal to become Newton meter square by kg square. Okay, clear or not? Yes, the value is 6.67 into 10 to the power of -11 Newton meter square by kg square. Yes, what is the necessity of the G value? Yes, there is taken a gravitational force between big masses and the small masses also. Somewhere time sphere, somewhere time there is a blocks or somewhere other structure. Whatever may be the structure is there. Okay, now the gravitational force is remains okay based on one constant value. Okay, now otherwise it will be difficult to find the gravitational force between any two bodies. That's why only this gravitational constant is used. Why? Because it is same for any body. You take for the gravitational constant on Sun, on Pluto, on Earth, on Moon, on you. Okay, clear or not? On you. Suppose on me there is one chalk piece is a fall on me. The chalk piece is a contain a same gravitational constant, and as well as my head is also contain same gravitational constant. Apple is a contain same gravitational constant. Newton head is also contain same gravitational constant. Earth is also contain same gravitational constant. Yes, this is a universally we required to find a gravitational force. There is a one gravitational constant is required. That is why we are taken. Yeah, please note down there is a unit. This part is enough. If you require, there is a definition of the G purpose. You have to write it in also. Definition of G. Yeah, the next concept. Next concept is significance of Newton laws of gravitation. Yeah, what is the significance is there for a Newton gravitational law? Yeah, what is the main significances are there here? Newton gravitational law purpose. Okay, clear or not, all the students? Five components are there. We consider the first component is for existence of solar system, for holding of the atmosphere near the surface of Earth, for the low water, for the flow of water in a rivers, and for a rainfall and the snowfall. There is so many things are may possible to discuss based on this thing only. And as well as there is already we are discussed. There is without a gravitation, these things are may not occur. Got it or not? Yes, all the rivers are flowing one direction only. You know very well. Got it or not? And as well as all the yes, the next component is for holding the atmosphere, total atmosphere, whatever there around the Earth. Okay, now because of which thing? Because of the atmosphere only, because of this gravitational force only, the atmosphere is as what covered our Earth. You know very well, we are living in a where we are living in a 300-kilometer depth of AC. Okay, above the Earth there is how much atmosphere is there? Up to 300 kilometers. Also we have atmosphere. Yes, 3,400 kilometers also our Earth gravitational force is there from the surface of Earth. Okay, clear or not? Yes, atmosphere is somewhat distance it will be there. How it is a hold with our Earth only? It will be not why the oxygen is going to the other planets. Okay, why? Because of gravitational forces only. We want to discuss these gravitational forces. Here there is what we are considered. What we are considered here. This gravitational law is explained. Okay, clear or not? How there is a gas molecules are collide with our Earth only. Why the river water is flows like that here Earth only. Okay, these are all the things we are taken by these gravitational forces only. Got it or not? And next one it is rainfall and snowfall. When you not get any doubt why there is always rain is come down only. Okay, why it will be not moving away from the earth. Okay, now how we discussed these all the things because of gravitational forces only. Yes, there is a rain is attracted towards the earth because of gravity of earth. Okay, clear or not? These are all the things we are discussed here only. Understood not all of you? These are only main significances. We are considered. Next one is the characteristics. Okay, next component is the characteristics of gravitational force. It's a very important BITS purpose and as well as the whatever our multiple choice question purpose. There is a characteristics of gravitational forces are also required. As characters of gravitational force. What is the characters here considered for the gravitational force? First thing is it is as a field force. You know very well. Action at a distance. We call it is a what? It may not touch with the body compulsory. Okay, clear or not? From some particular distance only, it will be works actually. That is only called what? Action at a distance. Action at a distance means what it is? It will be there is no need to touch these two masses here. Okay, now some particular distance only one is giving effect on another one. Understood not all of you? And the second part, the second character is what you know. The second character is it is inverse square force. Okay, why? Because we call F is directly proportional to 1 by R square or F is inversely proportional to the square of the distance. We call it is. Okay, now yes. And here there is a distance is increases between the two bodies, the force is decreases. Okay, clear or not? That is also again yes, in the which form it is decreases square of the distance. That is why this law is contained, these forces are contained. The main character is the what? Inverse square law. Inverse square law. Why we called inverse square law? Based on this particular component only. Yes, whatever the law it is contained like this. That is called inverse square law only. Yes, got it or not? Coulomb's inverse square law. That is getting in your electrostatic forces. Coulomb's inverse square law. Magnetic field inverse square law. Okay, that all are getting in based on this one only. When there is a distance between the two bodies are increases, the force is acting on the bodies are decreases. The force is acting on the bodies are decreases. Got it or not? And now that is why it is a called inverse square law. It is a called what? Inverse square law. Okay, clear or not? And as well as the next last character is what we have considered the gravitational force between the two bodies or objects from an action a reaction pair. If the object A attracts and as well as B is also attract. Okay, clear or not? Yes, there is a Earth is attracted the whatever this chalk piece it is there. The chalk piece also attracted the Earth towards it. Got it or not? Here Earth is only not attracted here. Yes, that is why only the painting may get now. Suppose you put your hand like this. Okay, now it will be coming, it will be attracted the earth also now. And earth is always attracted towards it. Yes, we don't know, but earth is also attracted by this my hand. Okay, clear or not? Yes, there is a suppose one mango is a fall towards the earth. Earth is only giving force on it. No. Okay, now mango is also attracted the earth towards it. Okay, clear or not? That's small but maybe, but it is attracted towards it. This is only about the, yes, it's a pair forces are working here. Pair forces are working, and the two are attraction forces. The two are attraction forces only, not a repelling forces. One is repelled, another one is attracted. Not like that. Both are attracted. One is towards another one. Okay, clear or not? That is only the nature. The character is contained by our gravitational force. These characters are important. The question may frame on these characters. Following is not a character of the gravitational force. May the following is the gravitational force character. Okay, like that questions are may frame. What is the main characters? One is the S action at a distance. Another one is the inverse square law. Another one is pair forces are contained. Pair forces are contained. Third point is what? Pair forces are contained. I hope you understood. Yes, and next there is what we are have here. Properties of gravitational forces. What the properties are there here? Does not depend on the medium lie between them. Yes, in the properties of gravitational forces, there is a no medium is there. Whatever the medium is there between that. Okay, clear or not? Suppose there is a this duster is there, this book is there. Okay, this book is there. There is a no gravitational force is working or not in on working here. Understand? If it is not working, it is a why it is fall down. It will be stay like this only. When I removed, it is also like this. Here only they have to stay. It is a book. It is there between the earth and as well as this duster. Okay, the medium is there here. Which medium? The book. Suppose the air is there. Extra to the air, which medium is there? This book is there. It is a fall down. Which force is working when it is a fall down? Gravitational force. What you understood? Meanwhile, the two bodies, any medium is also there. Okay, now there is a gravitational force is working. Okay, now between any two masses, the medium is there or not. Okay, the gravitational force is working. Between sun and us, somewhere medium is there, somewhere medium is not there. Totally vacuum. But the force is working or not? Yes, like that. The medium is there or not. The gravitational forces are working. Yes. And next one, second point, the gravitational force obey the Newton third law of motion. That is the gravitational force of attraction between the two bodies are contain action and reaction pair. Already now only discussed it. The third character. What is the third character? It is a contained pair of forces. Yes, one is action, another one is a reaction. Not a yes, repulsion, reaction. Don't confuse. Reaction is also one of the attraction only. Yes, action is also one of the attraction only. One is giving the attraction on another one in the form of action and a reaction. Got it or not? That is only the gravitational force in the obey the Newton third law. And next one, gravitation force is always attractive. Already I have discussed it so many times. There is a no repulsion. No body is repelled. And the second point, the fourth point is gravitational force is the weakest force among all the forces. You may get somewhat doubt what the forces are there, sir. So many types of forces are there: nuclear forces, electromagnetic forces, electrostatic forces. These forces are very, very strong forces. Atomic forces, nuclear forces, these are very, very, very strong forces. Strongest forces are nuclear forces. Okay, now the weakest forces are gravitational forces. This is the weak forces, not that much of strong forces compared with the other physical forces. And next to compare, gravitational forces is the conservative forces. They contain a constant. Okay, now yes, they contain a constant nature. It is not created by any other. It will be not possible to destroy by any other. Understand all of you? There is a changes. The gravitational forces are changes from one form to the other form, maybe. Okay, now yes, but it will be not okay. Yes, totally smashes. If it is totally smashes, universe is not like this, na. That's why it is a conservative force. The gravitational force is a conservative force. When the sun is formed till that day to this day, okay, this system is like this only. Means what? Constant or not? It is a constant force. Okay, now till the bodies are available in the same place. That is why it is a conservative nature. Okay, clear or not? And as well as Kepler is also given this one law. Okay, now the momentum whenever the body is revolving because of the gravitational forces. Okay, now that will be remains constant. When the momentum is remains constant, that is a conservative. Okay, the force is become conservative. And one more thing, these gravitational forces are central forces. Yes, always it's attracting towards the center. Yes, Hence, there is a center of mass based thing. This is, yeah, these are the main properties of our gravitational forces. All the students, it will be utilized to give the more presentation for your whatever our regular academic textbooks. Okay, once you read the total lesson, okay, extra knowledge you may get on this your gravitation lesson. Okay, yes, tomorrow we'll go with the numerical problems.